Good day, everyone. Today we're going to delve into our deployment automation process that utilizes Ansible, an open source software provisioning, configuration management, and application deployment tool. In our setup, we have a shell script known as run mrc.sh. This script is the starting point of our automation process, and its primary role is to execute Ansible playbook call main YAML. To ensure a security communication between our control node and the instances, we utilize a private SSH key known as private doc key. Understanding this sets of stage for our deep dive into Ansible-based deployment automation process. Our first phase is instance creation. This phase is fundamental to our setup and involves a number of crucial roles. The first role is OpenStack/common. This role is primarily responsible for installing PIP, the package installer for Python, and OpenStack SDK, a client library for building application to work with OpenStack on our control node. Following this, we have an OpenStack/volume role that takes care of creating volumes for the storage process purposes. Next, in line, we have the OpenStack/security group role that lays down the rules for our security groups to ensure proper network traffic management. And finally, we have the OpenStack/instance that takes care of spinning our instance on MRC. Our instance and volumes are all created in a specific availability zone, known as Melbourne QH2 UOM. And we utilize the specific OS image, the Nectar Ubuntu 20.04 LTS AMD 64. Next, let's discuss the security measures in our setup. For all our instances, we maintain a specific security group named group-64-2. This group is vital as it allows secure communication within our cluster while limiting external access. For the ports we have open, such as 5984 and 9100, encryption is vital to prevent potential exploits. We achieve these by using a transport layer security protocol, complemented by the use of certificates for enhancing security. An additional safeguard we implement is the exclusive use of secure encrypted connection for intra-cluster communication. This measure ensures further protection and sensitive data in transit. Therefore, the safety and security of our cluster communication is guaranteed. Our volume configuration plays a key role in data management. We have 4 distinct volumes: Web Apps, Harvester 1, Harvester 2, and Harvester 3. The Web App volume is allocated 50 units of storage, which primarily house codes and libraries. Hence, the smallest storage size conversely. Harvester 1, 2, 3 each have 150 units of storage allocated. These volumes are designed to handle data-intensive tasks such as storing and managing large datasets. If an instance fails, we can quickly detach these volumes and remount them to a new instance. This allows us to prevent data loss and ensure operational continuity. Once the instances are up and running, the next phase is virtual machine configuration. In this phase, we execute 3 roles across all instances. The setup/common role is of this, which helps install some essential packages and dependency for our Ubuntu environment on MRC. These include Docker, Docker Compose, PIP, and CouchDB. Following that, we have the setup/CouchDB rule, whose main function is to configure and establish a cluster, CouchDB cluster within our setup. The cluster comprises of 3 nodes, 1 master and 2 slaves. And finally, we have this setup/mount rule, which takes care of the setting up an XFS file system on the F/VDB device. It also manages installation of necessary packages, creation of data directory, mounts a device, and configure fstab file to ensure mount is persistent even after reboots. And in conclusion, our Ansible-based deployment automation process is designed to ensure maximum security and resilience of our system. It allows to efficiently store and manage data, all the while maintaining operational continuity. This process embodies the robustness and reliability we strive for in our digital operations. Our presentation ends here. Thank you for your time.